Number 8 from the same section. Is this set of vectors a basis for R3 is the question. So is this a basis for R3? All right. So remember, a basis has to satisfy two properties. They have to be linearly independent, and they have to span the space. All right. So we've got to satisfy those two properties if we can. And I suppose what we could do is see if they're linearly independent first. Let's try that. So remember, they're going to be linearly independent. If x1 times this plus x2 times this equals 0 implies the only solution is x1 equals x2 equals 0. So the quick way is to set up a system of equations, make all the right-hand sides equal to 0, and then put this in the right form. You could use a calculator, but on something like this, boy, it's almost as fast as just do it the hard way. Divide the first one by 4. And then maybe 4 times the first one plus the second one. And then -1 times the first one plus the third one. And then I guess we'd probably divide the second one by 9. And then, almost done, -2 times the second one plus the first one, 3 times the second one plus the third one. So it looks like the only solutions are the trivial solutions. All right, because we only have two variables, x1 and x2. Now I know this is not the pivot column, but the last column is never the pivot column or a pivot column. So there are only two basic variables, and they both have to be 0. So that means the only way that x1 times this plus x2 times this can be 0 is if x1 and x2 are both 0. That means linearly independent. Okay, now let's see if they span the space. So what I could do is just let b1, b2, b3 be an arbitrary vector in R3. Okay, and the only way that those two vectors will span the space is if there exists an x1 and an x2 such that x1 times this plus x2 times that is equal to those b's. Because if it spans the space, then every vector in R3 can be represented as a linear combination of those two vectors. So the system for that looks like this. Okay. Now I'm going to go through the same operations when I put this thing in reduced echelon form. The only thing that's really going to be different is the expressions for the b's. But all this stuff is going to end up looking the same. Okay. And the answer is it probably doesn't span the space as long as this doesn't just turn into a 0. And it probably doesn't, but let's go through the steps. Let's see, I'll just add, or I'll divide the first one by 4. Okay, now 4 times the first one plus the second one. Really, the only thing that's different are the b parts. Now divide the second one by 9. All right, now it looks like we want to say -2 times the second one plus the first one. We'll leave the second row alone. So -2 times that plus that. This is the tricky part. So it'll be really -2/9 b1 plus b2 plus b1 over 4. It looks like all that is the first element in that last column. It's kind of messy. It almost doesn't matter what it is, though, really. And now add the second row to the third row. So I'm going to get something like b1 plus b2 over 9 plus b3. But the point is that's not always 0. Okay. So in general, this is going to give you a contradiction because you have a row with all zeros except the last one not being zero in general. Okay, the fact that I can find B1, B2, and B3 to make that not zero means the system won't have a solution for those choices of B's. And, you know, if you just choose all positive B values, that'll be enough right there. So this thing definitely does not span the space. So it is not a basis, okay? You know, generally, in R3, you need three things to span the space. Just a little side comment there.